Hello and welcome. In this video, we are talking about networking, very specifically subnetting. My name is Arthur Solomon. I'm going to be working with you throughout this video. All right, so some assumptions. First of all, I am assuming that I'm going to grab my pencil. You can do binary to decimal conversions, and you can do decimal to binary conversions. Those are at least the math components. I'm assuming you can do adding and subtracting, basic multiplication, multiplying. Also, the last assumption is you understand why we subnet. So that's an important one because the goal that I'm focusing on is the subnetting portion. So again, I'm assuming you can do the conversions, you can do basic math, and you understand why we subnet. So with that said, let's jump in and let's see what we can do. All right, so I'm gonna grab my pen again. Page 1. So, first thing you'll notice, I have a blank canvas. So let's assume we are a 3-location network. So we have 3 branches, or we have 2 branches and a core network. R1, R2, R3. We are concerned with the interconnections between our networks. So they're going to be 2 hosts each. They're point-to-point through a cloud direct network. On our branch locations, R2 and R3, let's assume they're connected to a switch. And let's assume maybe 128 hosts. R2 has 2 networks, one with 30 hosts and one with 65 hosts. Maybe they have phones and they have staff, where R3, they don't have phones. R1, we have 2 networks. We'll have our data center, which will have 100 hosts, and our main staff we'll do 500 hosts. Our starting IP, again, the starting IP isn't really necessary, but it's just if you have an IT manager that's a little bit more particular, they may say, hey, the overall reaching address space that we want to work with is this. So we're going to go ahead and do a 10 network. And again, the IP address, the starting address can be anything you want. Assuming if you're doing public, then it might have to be a public address base. If you're doing private address, it could be any private address range that you want. And then again, we're going to be subnetting our network into these, I forgot to write the word hosts. We have, I'm going to change colors for our count. 1 network, 2 networks, 3, 4, 5, 6, 7, 8. We have 8 networks. So what we're going to do is we're going to work through and develop a subnet for these 8 networks. Another assumption is when we were given these addresses, maybe for our data center it had 100 hosts. Well, maybe it has 50 physical hosts or 50 hosts, and we're assuming growth over the next 3 years for that extra space. So we're assuming growth is built in to these addresses, to these host counts. So with that said, let's actually look at our addresses. All right, so step one, first thing we want to do is we want to rank, and I'm going to go page by page, just breaking out the problem. So again, here I'm going to change my pen back to red. Page 2, we're going to rank our addresses. So we have 8 of them. We're going to rank them greatest to least. So 500, 128, 100, 65, 30, 2, 2, and 2. So step 1, rank them greatest to least. Step 2, add 2 to all of them. Why are we adding 2? We know at the very end of all of this, what we're going to end up doing is we're going to lose an address for the ID, and we're going to lose an address for our broadcasts. So when we need 2 usable, we have to accommodate the ID and the broadcast. So that makes it a little bit more difficult. So if we add 2 at the very beginning, we can just build from that from scratch. All right, so, well, looking at these numbers, we can assume that we're doing variable length subnet masks, meaning each network is going to be different in size, because the subnet will be larger or smaller depending on what we need. We don't need a /22. /22 for all these networks. /22 gives us 512 addresses. Well, if we only need 32 addresses, why are we going to give it 512 addresses? So we're going to be doing what's called variable length subnet masks, meaning the masks can change based off of our requirements. All right, so some anatomy. An IP address is 4 groups of 8 bits, so a typical IP address might be 192.168.10.5. Again, each one of these are 8 bits. And whatever 168 isn't broken down and so forth. So when we do this, we're going to break this down into our binary. And I was just using 192.168 as an example. So with that anatomy broken down, we're going to be doing 4 groups of 8 bits. Starting on the far right-hand side, I'm going to build an address chart. The far right-hand side is the most important. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is our 3rd octet. This is our 4th octet. The 2nd and 1st octet I'm not going to be working with because, well, we already know that they're locked in. We already know that they're not going to be being worked with. We're dealing with 500 hosts. Well, this gives us 32,000 plus hosts. So yeah, we're well over our limit of what we need. So the first one that I do, this first number, I like to call my groups. Sometimes they're called blocks. And we just start with 1 and we double. 1, 2, 4, 8, 16, 32, 64, 128. At each decimal place, we just start over. So someone asked me at one point, why are we starting over? Well, in reality, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. That's actually how we get our numbers. We just assume that they're doubling, but it's actually binary math, and they're in the 0 position, the 1 position, the 2 position. that's actually how we get that doubling effect. So that is the first part. I had to change the tilt of my display because it's hurting my wrists. Alright, so the next one is our host. And again, we start with R1 and we just double it. 2, 4, 8, 16, 32, 64, 128. But this time we don't restart. 256, 512, 1048, 2096, 4000 plus 8,000, 16,000, 32,000. Again, we're not going to need past the 1,000 mark. That's why I wasn't as concerned. So, first step we do, again, working in the third and fourth octet. So that means there are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is our first octet. This is our second octet. We know there are going to be all ones because, again, we're dealing with small numbers. So, starting from the right-hand side, which will allow me to have a host count of 502. Well, that will give me 1, that will give me 2, 4, 8, 16, 32, 64, 128. Looking at our host count, this will give me 256 hosts. Oh, this will give me 512. I need 502. That works. That means anything to the left, which is larger, is going to be all ones. This tells us two pieces of information. This tells us our subnet and our group or block. Our subnet is 8 plus 8, that's 16, 17, 18, 19, 20, 21, 22, 23. So we have a /23. Our last one is in the 2 position. So we're going to have groups of 2. That just means that when we're increasing, we're going to increase by that group or block size. And that's going to make more sense once we figure out the group for all of them, because then we'll build out our address chart and then we'll put it on the next screen. So I'm going to erase and I'm going to repeat. I need 130. Well, this gives me 1, 2, 4, 8, 16, 32, 64. I need 130 addresses. 128 ain't going to cut it. This will give me 256. That's large enough, so everything to the left will be ones. That's a /24. And again, the last one is in the 1 position. Alright, I'm going to erase. This is why we rank them greatest to smallest, greatest to least. Makes building out this address chart a lot easier. Next one is 102. 64, nope. 128, yes. Everything to the left. So this is 8 plus 8 plus 8 plus 1. That's a /25. The last one is in the 128 position. So how did we get 25 ones? Again, 8 ones from the first octet, 8 ones from the second octet, 8 ones from the third octet, so that's 24. 8 plus 8 plus 8 is 24. And then this one right here is our 25th one. They're all going to be smaller numbers, so I'm going to stop erasing the third octet because, well, in reality, they're all going to be ones from here on out. So, yeah. All right. Our fourth network is 67. We're going to rinse and repeat. Nope, 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 nope. 64 is close, but 64 is smaller, so nope. 128. So again, /25, 128. Next is 32. And again, the assumption was growth was already put in. So nope, 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 nope. We need 32 addresses. This gives us 32 addresses. We have a group of 32, and we have 8 plus 8 plus 8. That's 25, 26, 27 /27. All right, and then we have our small interconnections, our 4 networks. Nope, nope, yes. These are all /30. With a group of 4. Again, the slash number is just a different way to write the subnet, whether it's dotted decimal. So for example, /24. I said 24 but wrote 25. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. Or 255, 255, 255.0. Slash notation, dotted decimal. If we did a /25, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4. 255, 255, 255, 128. So we could either do dotted decimal or slash notation. It doesn't matter which one. So I opted to go with the slash notation. Made it a little bit easier. All right, so normally when I do these problems, I do it on an individual sheet of paper, and I go through the paper as necessary because sometimes room's an issue. So I'm actually going to go to the next page so that we can write out our subnet and group, make this a little bit easier. All right, so with that said, let's go to page 3. All right. All right, so with that said, I'm going to rewrite some of this. We had our host count. So I did 502. We have our subnets. We have our group or block. So 130, 102, 67, 32, 4, 4, and 4. This gives us a /23, /24, /25, /25, /27, 30, 30, 30, 2, 1, 128, 128, 32, 4, 4, and 4. Network ID. All right, we said we're starting with the 10 address. So what we need to do, very, very simple. Yeah, so for the first network, we need 502 hosts. We have a subnet of 23, or /23. /23 means we're working in the 3rd and 4th octet. That means the 3rd and 4th octet are not full of 1s in the subnet. That does mean the 1st and 2nd octet, I'm going to do /21 or /23. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. that means 10 and 0 are locked in. We don't get to modify them whatsoever. We can modify the third and fourth octet. That's it. That's what we're going to do. So in the third octet, we're going to add our group. Our group is 2. So plus 2 in the third octet. First network done. I'm going to adjust this a little bit because I did not draw those very straight. So for network 2, for a host of 130, /24 is in the third octet. We're going to add 1 to the third octet. Well, I can already hear, oh, well, wait, /24. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, wait, the third octet is full. How does that work? These are special cases when it's a /8 /16 or /24, the boundaries. So when we are falling on a boundary limit, we are allowed to add 1 to that same octet in the 8, 16, or 24 ranges. That's just something that's weird when they did it, so that's how it's applied. Alright, so that takes care of the first 3 networks. So that one is done. That one is done. So 102. We have a /25. Oh wait, /25, the first, second, and third octet are now locked. /25 is in the fourth octet. So that means we're going to add 128 in the fourth octet. Third network's done. Fourth network, we're going to add another 128 to the fourth octet. So add 128 plus 128 is 256. However, 1, 2, 3, 4, 5, 6, 7, 8. 255 is as large as we can go. So what that means is, if you ever have to go above 256, you carry the number. You carry the 1. Alright, that takes care of that guy. Next, we go to the network that needs 32 hosts. /27 in the fourth octet, we're adding 32. Alright, that guy is done. And we're going to repeat for the next 3 networks. I'm just going to stop adding the 4. You guys can do that. So dot 36, dot 40, dot 44. Yep. So another thing is, wait, we have 1, 2, 3, 4, 5, 6, 7, 8 addresses. But we have 9 network IDs. How does that work out? Remember, we started with 0. So 10,000, there's already there. And then there's 8 additional networks because that's how many networks we had. 1, 2, 3, 4, 5, 6, 7, 8. There's a reason we do this type of structure. Rank them greatest to least. Find the subnet. Find the block size. Find the IDs. This is the easiest way to handle this part. So now let's do our broadcasts. We do our start, we do our end, makes finding the middle way easier. Our broadcast is very simple. The rule for the broadcast is you look at the next ID and subtract 1. So for the first network, actually I'm going to attempt to draw straight lines at the straightest I can draw them. It's on the bottom of my drawing tablet, so. Alright, good as I got. So, for our broadcast for the first network, we look at the next ID. 10.02.0. We're minusing 1 from the 4th octet. Well, in reality, that I'm going to break down 2.0 into binary. 0, 0, 0, 0, 0. 0, minus 1. Well, we can't subtract 1 from zeros, so what we can do is we borrow. And when we borrow, that makes them all. If we add 1 to that, then it goes back to 2.0. So this new number is 0.111111111, or in decimal 10. Actually, I'm going to draw it more towards the edge. 10.0.1.255. Remember, in binary, with groups of 8, 255 is the largest number before you have to carry to the next place. So, broadcast for the first network, done. Broadcast for the next network. So for the second network, we look at the third network, 3.0, subtract 1 for the 4th octet. All right. So for the third network, we look at the 4th network and subtract 1 from the 4th octet. Oh, wait, that's not a 0. We can subtract 1 from 128, so that becomes 10.0.3.127. For the 4th network, we look at the 5th network. We can't subtract 1 from 0, so that becomes 3.255. To do the 1, 2, 3, 4, 5th network, we look at the 6th network. 10.04.31, because again, we're subtracting 1 bit from the next ID. And then you guys can finish the chart. Again, we're looking at the next ID, 35. 39. Well, how do I do this bottom number? Well, we don't have to. We only need address spaces for 8 networks. The last network's for growth. That's why we did that type of structure, so we can accommodate our 8 networks. All right, we are almost done. The last thing we have to do is the range. The range is everything in the middle. Again, these are number lines. We want to accommodate every single possible number. So we're going to add 1 in the 4th octet for the start, and we're going to subtract 1 from the broadcasts for the end number. That way, we've now accommodated for every single number between 10.0.0.0 through 10.0.1.255. Every single possibility is now accounted for. A common mistake is I see, if you do 1.0 for your start, what happened to 0.5 or 0.10 or things like that? That's why we make sure the range, we start with 1 to the network ID in the 4th octet, and it goes through 1 less than the broadcast. These are number ranges. And then we just go through and we finish the chart. 2.1, 3.1, 0.3. Again, we're adding 1 to the 4th octet. Here we have 128, so we're adding 1 to that. Another common mistake is I get 1.1 again. We can't have 2 duplicate addresses. So again, we want to make sure to remember add to that network ID. Row 33. And again, we go through 1 less than the broadcast. 10.0.3.126. Again, 127, so we are going 1 less than that. 254. 10.0.4.30. Again, we needed 32 addresses or 30 usable addresses. 1 through 30 gives us 30 usable addresses, so we're good there. And on some of these smaller networks, we needed 2 usable addresses. So when we look at some of them, it's like, wait, this network right here gives us 10.04.33 through 10.04.34. That's only 2 addresses. But that's all we needed. So that's why that's acceptable. We only needed that many addresses, so it worked out. And I found a typo on my part. I did 1 less instead of 1 add, so 40, 41. We all make mistakes. 37, 38. Again, we are going to double check at the very end. All right, so we're done. So again, what we normally want to do is we double check. We look at our ID, make sure the starting range is 1 addition. So 0001, 2021, 3031, 128, 3.129, 4.0, 4.1, 4.32, 4.33, 4.36, 4.37, 4.40, 4.41. We're good. Always double check your work because it's really common to do a quick little typo and it throws everything off. So that's subnetting. So the next step might be you had asked questions. If I want to assign the first usable address in the 4th network to the router, what IP is that? I'm going to grab a different color. So 1, 2, 3, 4. First usable is 10.03.129 with a subnet of a /25. That's the subnet for the 4th network. The subnet tells us what our block size is and what networks we're allowed to play with, which octets we're allowed to play with. But that does mean when we write the IP address, we need to include the subnet. They go hand in hand. All right, so let's ask another question. I want to assign the last usable in the second network to the printer. 1, 2, second network. Last usable with that subnet. There you go. Alright, so that is subnetting in a nutshell. Now, typically early on, this is probably the hardest concept to get people's minds wrapped around, but once you go through the binary math way and do a little practice, it is not hard. The easiest way to practice: generate 3 large numbers, do your 3 interconnections of 2 hosts each. Actually, I'm going to go to the next slide. For practice. Do 3 networks. Two hosts. Make up any number between 4 and, keep it simple, 32,000. And make them up 3 times. So make up a number for here, make up a number for here, make up a number for here. Rinse, repeat. Rank them greatest to least. Find their subnet. Find their, page 4, find their block size, their grouping size. Start with the IDs. Do the broadcasts. Do the range. Practice, practice, practice. That is the best way to get this down. I have found that this has helped both in networking and in cybersecurity. Understanding the address portion of the network is important. Not the easiest to do, but relatively easy once you go through it a few times. Alright, so that's it for this video. Questions, concerns, let me know and we'll work through additional problems. If you need it explained in a further detail, again, say something. I can do another video, not a big deal. If you need another example, again, say something. We can work out what we can do. Thank you.